Hello, welcome back to the channel. This is the basics of Diag, and today we are looking at a 2008 Suzuki Swift with the 1.3 diesel engine in it. I think it's a Vauxhall engine. The vehicle owner's concern is it's not starting very well. There's an extended crank apparently. However, now that the weather has got a bit warmer, it's not doing it as much or as badly. So maybe we will hear the fault. In the interest of clarity, I had a quick look at this a couple of weeks ago, so I'm going to set the test up before I show you the fault. It sounds like the battery is a bit weak, cranking speed's a bit slow, and yeah, I've got my little Think Diag dongle plugged in, because also we were getting the little car with the spanner through it warning light, but now the EML is on as well, so we're gonna have to see where this leads, aren't we? So let's get the first test hooked up and then we'll start it, and hopefully the fault will be present, obvious for all to see. Okay, so we'll just set up here, measuring battery voltage. Now I am using this Oscilloscope 2203, but you don't need a Oscilloscope or an oscilloscope to measure this. All I'm doing is just measuring battery voltage during engine cranking. So a decent multimeter will be able to show you that. However, I picked this up for a lot cheaper than a decent multimeter. I think I'm going to do a video on this, like a standalone video on its own, because this is a bargain way into Oscilloscope. You can use it with Oscilloscope software. Yeah, so if you are just starting out on an oscilloscope journey, I would recommend looking for a second-hand, older model like this is. Anyway, let's see what happens to this battery voltage, and we can maybe hear this extended crank as well. Also, this light is flashing. This is this car with spanner light that I was talking about. I'm pretty sure that should be on with ignition on and then go out when the engine is running. Not sure it should be flashing, but hey, see what happens. Right, ignition on. Let's just bring a cursor down and see what the voltage measurement is. 11.77. It's probably already a little bit low, and we're going to go for a crank. Right, well that didn't actually crank for as long as it has done in the past, which is a bit annoying. If I zoom in into here, we can see that the battery is indeed weak. We have an average voltage of about 9 volts. So it's probably going to need a battery, but I don't think that is the entire story with this car. So we're going to scan it now, see what's lurking beneath. Right, we've had a slight change of plan. The way I've got this set up isn't going to work. I've got it connected to this old mobile phone. However, you need an internet connection for this to work. but there's no SIM card in this, and I'm too far away from the Wi-Fi for it to work. I was going to use this phone that I'm recording video on, but I haven't got a screen recorder downloaded on it yet, so we're just going to go old school with my Snap-on Modus Ultra, and let's get scanning. Let's try and reduce the glare a bit. I'll have to manually select Swift. Oh, I think it's Z13DT. We'll just do a full code scan. Right, so 4 systems and just 2 codes in the engine. So we've got the glow plug control module to ECM communication circuit, and then we've got EGR flow. So we could end up having 2 separate issues here. We'll just have to communicate with the vehicle owner everything we see, what we think. One fix might not make all the warning lights go out, so I'm just going to clear these now and see if we can duplicate a fault or a fault code. Now that this has been running for a little bit, it's a bit warm, so I've got the aircon on. But now that it's been running, the engine's going to be warm, the cylinder temperatures are going to be hot. Glow plugs probably not going to be necessary to start this vehicle, so it may start up like that. But we'll do a code clear, and then I'll cycle the ignition, start it up a couple of times, and see what faults return. Key on, engine off. Engine must be running to clear codes, really? Well, that's a first. Holy moly. Turn the engine off and ignition back on. Did I read that right? Huh? Right, we'll just go into engine. Make sure okay, no codes present, so ignition off, ignition on, start it. Let's read codes again. No codes. We may need to let this cool down, because obviously if it's not using the glow plugs because the engine temperature is hot enough, it may never bring up a fault code. Okay, we'll just go in again. Oh, hello, that's me. Codes. Right, there we are. Same fault code, P0683. glow plug control module to ECM communication circuit. Now that took maybe 3 or 4 engine sort of cycles on, ignition off, on, start it, turn it off, ignition on, start it. I might just clear it again, make sure I can replicate this one more time, and then we can move on to looking at a wiring diagram, locating the glow plug module, and then either, well, if you're in a workshop, contacting the customer to let them know how long you need to test that module, wire into it, powers, grounds, communication. If it's a nightmare to access, take that into consideration. We're not in a workshop setting, so it depends your pricing structure as well in your workshop, doesn't it? If you charge 300 quid as a minimum for sort of Diag work, then this work we're going to do is going to be included in that. If you charge an hour's labour just for sort of your first step of the diagnosis, maybe it's an hour, maybe it's an hour and a half, you need to think about whether you can access that module, test that module, reassemble everything within the time that is allotted. If not, then yeah, you're going to have to prepare a quotation for further diagnosis. Anyway, let's have a look at wiring diagram. Okay, so we're going to look at the wiring diagram now, and I have to say, having never looked at a genuine Suzuki wiring diagram before, if these are genuine Suzuki wiring diagrams, they are rather nice. Everything's labelled, colour coded, just easy to follow. So our glow plug module, or glow controller as it's labelled here, is kind of top centre screen there. It has got, what's it got? A few wires in and out of it, so we'll just start from the right hand side. So bottom right of the glow controller, labelled 31, is a permanent ground. That black wire, we follow it down to a ground. Moving along, the green wire G1, the white wire G2. Each one of them supplies 2 glow plugs. Don't think it says which cylinder, but it doesn't matter, does it? Moving along to blue and the grey and blue wires, both of them go to the engine control module. So one of them is likely to be this communication wire that is listed in the fault code. I don't know which one yet, so yeah, a bit of scoping will hopefully show us the way. Above that, the red wire, terminal 30, is a permanent power by the looks of it, from an 80 amp fuse. And then top right isn't actually labelled in the glow controller. It looks like it's pin 1 on the connector, black and white wire. That is shared by a number of things from the looks of it. So it goes round to the brake light switch. Then we need to move on to the next page of the diagram. If we look, there's a box with a number 1 and an arrow on it. We need to find that on this next section of diagram, and it's kind of here above the cooling fan relay, and that goes into the fuel pump relay, and then that's got a number 2 on it with an arrow. So we need to move to the next diagram, number 2 with an arrow, follow it along. That comes from a 15 amp fuse, which is ignition power by the looks of it, but then that also powers the engine control module. It's spliced into the clutch switch. We've got a number 3 in a box, so we need to move on to another page of the diagram, and that supplies the air conditioning compressor relay. The aircon works, so I don't think this power supply is an issue. We've got brake lights work, don't they? There's nothing else related to what this wire is connected to. There's no faults related to what this wire is connected to. But let's just look. There's a number 4 in a box with an arrow, so we'll find the number 4 in a box with an arrow, and it's there, and that supplies the airflow meter as well with an ignition feed. So let's scroll back, and there we are. So that's the diagram. We've got a permanent ground, a permanent power, we've got an ignition power, we've got 2 supplies to the glow plugs, and then we've got 2 wires that we don't know what they do just yet that come from the engine control module. And our glow plug relay is just down here. You can just about see it. So we need this intake pipe out, maybe the headlight out if the bumper doesn't have to be removed. Yeah, kind of there it is. And also, this warning's come on now, so I am going to assume that we've got a fault code again. Now I've just been inside to download them wiring diagrams because I didn't have them. I've had to download them onto my phone, so we'll just scan it and see if that code. There we are. The code has returned, so I know can be replicated. I just need to leave maybe 5 or 10 minutes or so between, I guess, clearing it and then re-scanning it, starting it up or whatever. The real test is going to be leaving it overnight, obviously when it's fixed, leaving it overnight and then trying it. But we'll get into getting access to this relay and then we'll come back when it's time to test. We have access now. I've had to move airbox out the way, little intake pipe, and this just kind of slots into this bracket here. I've obviously moved it out of the way for testing purposes. So you can see we've got the red main power supply, we've got a black, which was the ground, black and white, which was an ignition power supply, the green and the white, which fed the glow plugs, and then these 2 small gauge wires were the communication from the ECU. So I'm going to check powers and grounds first, then I'm going to check the supply to the glow plugs, and then we'll check communication. So I've got my cheap £10 test light. The clamps just about had it, falling apart on me today. Clamped onto ground, and when we probe a power supply, bulb will light and we'll get a voltage on the display. I'm back probed into this red wire, which is our permanent power. So let's probe it and see what happens. We get a bulb and 12 volts. What I have got as well is just this H7 bulb sort of glued into an old aerosol lid. There's actually 2 bulbs on this. We know that fuse supplying that red wire is 80 amps, so I could probably wire both of these bulbs in, and if they both light, there's just a bit of extra load in the circuit because this is only maybe 300 milliamps of current draw. So I'm going to just hook this up, and hopefully they both light up. So they're both back probed into that red wire. I've moved this onto our ignition live, ready for the next test, and we just, where's the ground, touch this ground onto here. Both bulbs light, and that's about 8 amps of current draw there with 2 H7 bulbs. So next we want to turn ignition on and make sure this has got ignition power. If I put the test light in now, we shouldn't have anything, and we don't. Ignition on, we can see the test light just through there, and now it's lit up. 11.3 volts. and across the battery is 11.4, so that's okay. Right, now we want to check the ground. It's a permanent ground. Move the back probe to the black wire. I can't see very well. That's not in that well. So my clamp is now on positive, and when I probe negative, we get a green light in the bulb. So let's just go on to here. Green light and a bulb. I am going to again use this H7 test light. I'll just push that into there. Touch this on positive. Is that in properly? Right, got a proper connection in there now. Touch positive. Bulb lights. Nice and bright. So the ground is okay to this module. Permanent power is okay. Ignition power is okay. I should probably put the H7 bulb on that as well, because I think that was a 15 amp fuse, wasn't it? But I'm fairly confident. Next I want to check continuity from this green wire and the white wire to earth, to ground. Obviously they go to the glow plugs, and the glow plugs are grounded through the cylinder head. If we have a faulty glow plug, we should get some sort of voltage drop. The only problem we've got is one wire is supplying 2 glow plugs, so we could have one faulty glow plug on each circuit, but the good glow plug is allowing current flow. So we are going to stay clipped onto positive, probe a negative. I'm just going to front probe it this time, the module unplugged. So we are here. Let's go down, and we get 11.8 volts with the bulb lit. This other side, 10.7. So we've got an issue on the white wire. Now I have already traced this. It comes under here into this connector. So this somewhere is spliced into 4 wires, but from here I can test each glow plug. We've got 4 pins in there, if you can see, 4 populated pins in that connector. So we'll just go along them all with the test light. And that one, faulty. That one's faulty. That one's faulty. That one is not. We've got 11.8, 10.8, and then these two, nothing at all. Now the next step would be just to test across each glow plug, confirm whether it's the glow plug that's at fault or the wiring. However, I don't know if you can see just the corrosion build up down there. I can't get these plugs off. Like this bit, the plastic bit is just kind of peeling back the actual metal connector, it's just rusted onto the glow plug. So I'm going to say I need a set of glow plugs, a set of glow plug leads. Hopefully it'll come just as this loom here, this bit of loom unclips from this conduit. Set of glow plugs, they're probably going to be well tight in there. And then one last thing to check now, we need to plug this module back in and then test the communication wires with the oscilloscope. Right, we've got our oscilloscope connected up, just like a multimeter. You've got a black lead and a, well, red lead or blue lead. So black lead goes to earth, or blue lead is in the blue wire. We've got a second channel, again black lead on earth, red lead into the other wire. Can't remember what colour it was, grey is it, and blue. Now some of you might think a multimeter is sufficient, it's just a glow plug fault, what do we need an oscilloscope for? Hopefully when we start looking at these two wires, the voltages on these wires, it will become clear. But an oscilloscope is something that you don't need to fear. It's just a voltmeter. You connect it up the same as you would connect up your voltmeter. I've just showed you. Black lead, good to ground most of the time, depending on what it is you're testing. And then your red lead, or in this case, because you can have up to 4, well, you could have up to 8, but most commonly 4 channels. You have a different coloured lead for each channel. So our red lead on our channel A is blue. Red lead on channel B is red. Channel C would be green, I think, and channel D would be yellow. We've only got a 2-channel scope here, so that doesn't matter. And then instead of an oscilloscope displaying the voltage as a number, it's going to display it as a graph, and it's going to show you how the voltage changes over time. I should probably set up a multimeter as well and show you the difference between the two. Right, we're set up. I've got 50 seconds across the screen. Ignition's off, and then I'm just going to press play, turn the ignition on. Then we're just going to wait, because obviously glow plugs are on for a specific amount of time. I just want to see what happens. I can hear the fuel pump buzzing. The fuel pump stopped buzzing. How long was that? It's about 20 seconds, is it? Is anything else going to happen? What if I go to crank it? The battery's a bit weak at the minute. Battery's very weak at the minute. That's ignition off. Ignition on again, fuel pump buzzing. Fuel pump stops. We get that spike on the second channel, red channel. Okay, and then ignition off. So what can we see from this then? Well, we can see, we know from the diagram that both of these wires go to the engine control module. And obviously with ignition off in here, we are getting basically 0 volts. Zero volts on both channels, okay? Then when we turn ignition on, which was here, we get a spike of voltage on channel A. Let me just try and zoom into that a bit better. Oh, no. There's a spike of voltage on channel A, and then channel B is turned on. We get, it's probably battery voltage. It needs a new battery, this really, as well. Then channel A turns off, channel B turns off, channel A turns on again, and then we have however long this is between here and here, 22.97 seconds. That is, I'm assuming that's our glow plug on time. Then the fuel pump shuts off. Immediately after that, this red channel spikes. So we have got control. This engine control module is obviously, it's switching these voltages. We have got control by the ECU. Be honest, I was expecting to see a LIN signal of some sort, but it is what it is. This is going to need a glow plug module and glow plugs and glow plug leads, wires, and a battery. I think I'm going to replace all that and hopefully show you the fix. And then obviously the vehicle owner needs to be made aware there was that EGR flow fault, so that could be another video down the line. For now, I need to order some parts. Right, so 4 glow plugs are in. Got some Bosch ones in there. The glow plug module replaced, that's the old one. This is actually a Saab one of the same part number. So now we're just gonna clear the codes and then try and start it a few times. We'll have to leave it overnight, I think, and then double check, make sure that fault code hasn't returned. The customer said they're going to supply and fit their own battery, so for now, yeah, the battery hasn't been replaced. The glow plugs and that control module were supplied by the customer. All that I ask is that they are genuine items, really, or, you know, decent brands. So we've got Bosch glow plugs and that glow plug module. I gave them the part number off the old one, and then they've obviously gone into eBay, typed it, and it's come as a Saab one, but it did have GM stamped on the control unit, so I'm happy that it is good quality. Obviously, if there is any issues, warranty may be a bit of a nightmare being an eBay part, but I don't think it was used. I think it was sort of brand new old stock. So we'll get this plugged in, get the codes cleared. So we're just going into a full code scan again. So key on, engine off. Mass airflow, I had to take the airbox out to do that. This EGR flow seems to be a recurring code, so we may be into that at some point. Glow plug circuit, obviously we've been messing around with that, so we'll just do clear all codes read by scan, key on, engine off. It's a bit odd, and then turn key off and ignition back on. Did I say earlier that that is weird last time, a couple of days ago? I've never seen that before. Alright, so they've all cleared. Just start it up a couple of times. I'm probably going to leave it a couple of hours. It's Friday evening, I've finished work. So I've just come to this after work. I might, leave it a couple of hours, come back to it, see if we get any faults returning. I'll let you know. Right, it's the following morning now, and we're just going to go for a start up. You can hear, obviously we know fuel pump priming, the oscilloscope measurements we took, that the glow plugs are on, or they should be on when the fuel pump is on. Oh no, this battery situation really needs to get sorted. Oh no. Right, well I can't start it, but what I have got is current clamp and a multimeter. We're just going to measure the current flow around each of the glow plug wires. In all fairness, I probably should have done this before the fix, but forgot, didn't I? So we've got just a Sealy current clamp. What is it? 80 amp, 20 amp or 80 amp mode. We're going for 20 amp mode, and that says 100 millivolts equals 1 amp. So I've got the multimeter set onto 2 volts. Just need to zero the clamp. And let's get set up. That's high. Okay, so what we had there was about an average of 5 amps across each glow plug. Now that first cylinder, I said, oh, that's high. Now that is because it takes more current to get the glow plug up to temperature initially, and then it takes less current to keep it at a particular temperature. Could also be down to resistance, couldn't it? As the glow plug heats up, does the resistance inside it change, increase? And if resistance increases, current flow increases. Current flow decreases, sorry. Either way, we had plenty of current flow across each glow plug, which means the module's doing its job. And yeah, let's just check fault codes. So engine, keys on, codes, no codes present is what that says. I am just gonna get this going off camera, and yeah, I don't think we're going to get any fault codes present now. So that is it. If anything does change and this fault returns, this won't be the end. If not, this is the end. Should we scope the 2 communication wires? at the module? I think we should. This isn't the end. We should really see what them two communication wires are doing now that it's fixed. It may just be exactly the same, but having never scoped one before, I don't know, and I want to know. Right, let's have a look. We're ignition off, as we were previous. Again, 50 seconds across the screen. I've got the blue channel, blue lead back in the blue wire. Red lead is in the other wire, which was great, I think. We're just going to turn ignition on. I need to press play first. I'm going to press play and then ignition on. And I don't know if you remember from last time, once ignition was on, we got this spike, but then both of these channels were at 0 volts. And then when it timed out, the red channel shot back up to 12 volts like that. Blue channel obviously was still at 0 volts. And that's ignition off. So we can see now. Did I save that other waveform? Oh, it wasn't on this laptop. I've got the footage, I've watched it back, and we could see this blue channel wasn't doing what it should. This was permanently at ground. So that is going to be where the ECU is complaining of a communication fault. We haven't got that now because, yeah, this looks, well, I say it looks good. It must be good with no faults. It's different to how it was after replacing parts. So there we go. That is the end of this video. And what can we take away from it? Well, the checks we do on this glow plug module. Obviously, it's a control unit. They're all checks you could do on an engine control module, body control module, airbag, ABS control module. We just checked it had its power supply, its ground, the necessary communication wires. It could be a LIN bus, it could be CAN bus, depending on the type of module it is. But these basic checks that we carry out on this 50 quid glow plug module are all the same checks that you should carry out on a £500 airbag module, a £1,000 engine control module. If you suspect it's faulty, you need to make sure the power supplies, the grounds, the communication wires are all doing as they should be doing. And yeah, it's just once you start looking at diagnosing a few module faults, you'll come to realise that they're all pretty much the same, albeit body control, engine control modules are going to have a lot more wires. You need to make sure you have the correct wiring diagram. If you've got a diagram that is missing a ground, you think you've checked all the wires, but this one ground isn't on this diagram, and you obviously suspect or decide the module is to blame, you're going to be in a bit of pain when that module doesn't fix it. So yes, correct information is probably top of the list, really. Obviously you need to know how to test, you need to have tools to test, but information is critical. Anyway, that's enough. We will see you next time. Maybe it'll be this again. We still might have that EGR flow fault that's present. But yeah, I'm just going to get this going. Obviously, the owner knows this battery is no good, but they didn't want me to change it just yet. I think they wanted to see how expensive this glow plug fault was going to be. But yeah, that's it.
Connection established.